Welcome to today's webinar brought to you by Cube, Snowplow, Ascend.io, and Materialize. I'm Stephen Fagg, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Modernizing Your Data Management Strategy for the AI Era. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box and click on the submit button. We're going to try to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us David Jayatilaka, VP of AI at Cube, Yali Sassoon, co-founder and chief technology officer at Snowplow, Sean Knapp, founder and CEO of Ascend.io, and Seth Wiesman, Director of Field Engineering at Materialize. So, each speaker today is going to deliver a brief presentation, and then we're going to dive into a group discussion. So without further ado, I'm going to pass the event over to our first speaker today. Welcome to the broadcast, David.
Thanks so much, Stephen. Great to be on here. So a bit about me first. I'm David. I'm VP of AI at Cube. Previously, I was running a startup called Delphi Labs, which built an AI interface on top of semantic layers like Cube, and Cube being one of our very good partners was how we ended up joining. At Cube, I look after AI products and essentially how can AI interact with the semantic layer, whether that's in development or in production. And so I'll talk about some of those pieces today. So one of the first things that I should really go through is, what semantic layers are. And semantic layers are essentially what your data means and how to use it. So if you've got a data warehouse with many SQL tables, people write code to join those tables together, aggregate them, and come up with business answers. Now, the problem with that is that these semantic layers today are mostly everywhere. They're in Excel, they're in your BI tool, and so you get inconsistent and ungoverned metrics in many different places. And it would be much better to have these in one place. We could govern it in one place and reuse that definition across many different places. And this would simplify not only engineering and looking after those definitions, but also access, exploration, and trust in those things. And also would improve query performance and time to answer. And so that's why we believe there's a genuine need for a universal semantic layer. We have so many tools accessing the same data in different ways. We need a way for them to access this in a consistent and safe manner. And so this is what we offer as part of Cube Cloud. We offer a universal semantic layer, and we offer a modeling language where you can define and codify this business logic, abstract entities from data structures, define how those data structures should be aggregated and joined together. And you do it once, and you do it in a governed way for your whole organization. And this optimizes for speed and cost savings, both in terms of effort and also in terms of querying and compute costs. And we have rich APIs in terms of REST, GraphQL, SQL, and we integrate with many tools, both in terms of data sources, but also consumption tools and data orchestrators. And so this is a bit of an overview about what our platform entails. So we have that data modeling layer that I described, where you can define your data model, and this could be like how your silver layer joins together in medallion architecture. And you can define this in YAML, JavaScript, Python in your data modeling layer, and you can define role-based access control at this level as well, and column and row level security as well here. We also have a state-of-the-art cache for OLAP, And what that means is you can pre-aggregate certain grains without being constrained to having, marked layer tables which have got fixed grain for performance. You can do this using pre-aggregations in Cube. And what will happen is if that pre-aggregation does not fit the query coming in, the query can still pass through and run a fresh query against the data warehouse, which we then can cache as well in case a similar query comes through again. And as I described before, we have APIs and SDKs for React, Angular, Vue, and we integrate with many, many tools and now AI. And here's just like a subset of some of the tools that we integrate with. So you can think of every major data warehouse, pretty much every major BI tool out there, and a whole bunch of other things as well. So I think this comes back to the heart of what I do and where I've come from before joining Cube is there was a time where there were lots of companies being founded and making a lot of noise, doing a method that I'd call text to SQL. And this is where you use an LLM to generate a SQL query to answer questions. And what happens when you use this method is that the LLM defines what the data means, how to join it together, how to aggregate it, and also interprets the question in one shot or maybe in a couple, and tries to answer a question. And most people who work in data know that schemas in data warehouses are not usually clean enough for anyone to just go and look at them and understand what they mean. And the same is true for LLMs. There's no magic involved. They also struggle. And what we've found is on a very clean one table data set, they do very well. As soon as it goes more like into a bigger data set, they really struggle to get the joins right and come up with wrong answers most of the time. And so what we built at Delphi and now at Cube is another method that we call text to semantic layer. And what we do here is the LLM is restricted to objects that are defined in the semantic layer. So measures and dimensions that already exist in the semantic layer that an engineer has already defined using their Cube semantic layer. And so it finds what's available to answer the question with, chooses those to answer the question. So we'll choose specific objects from that semantic layer to answer any given question, and then forms a JSON REST API request using those objects. And so what you find is there's constraint on two levels: constraint in what it can choose, and constraint in that it's only asking for them and it's not writing code to retrieve them. And so what's happening is that the Cube semantic layer is deterministically compiling that request into executable SQL on the data warehouse, which then provides a much higher level of safety and accuracy than is possible with text to SQL. And, this is exactly what we were talking about. And you see here an example of this kind of chatbot. And we think this method will accelerate agent frameworks that we're seeing coming out this year, where multi-use agents will want to also have OLAP use cases. And so interacting with this kind of API with Cube will massively improve the ability of these agents to answer analytical questions for business stakeholders. And so here's like roughly what the architecture looks like in terms of the user asks their question, this universal semantic layer provides the objects to the LLM to form the query. The LLM forms the Cube query. Cube deterministically generates the SQL, runs it against the data warehouse, gets the result back, and gives the response to the user. And so this is one of the things that we've released at Cube, which is our AI API, and it implements this exact method. And so very easily, instead of someone having to build their own retrieval augmented generation or having to integrate with our APIs themselves, we've built that as a turnkey solution where actually interacting with our AI API is as simple as sending an array of messages, and it can just be one message, which is the user and their question. This AI API respects all of our role-based access control and row and column level security according to what the user should have as well. And so this really makes it easy for our customers to get started with allowing AI access to data, and this is safe, governed access to their data. And so the Cube platform has benefits for many different personas in your organization, whether that's data leaders, data engineers, business users, and analysts. So we provide benefits to all of those groups and not just the technical audience. We have our catalog, which helps business users discover what's in the semantic layer, plus our AI API and AI assistant, which allows them to self-serve. Our data engineers get this code first orientation that they want from using our data modeling language to define the semantic layer and using our RBAC controls to easily secure their data access for stakeholders and users. And data leaders get cost optimization and a huge amount of efficiency from using Cube and deploying Cube and having that governance of the meaning of data in one place. And analysts can also get involved in enjoying some of the same benefits as the business users, but also being able to use our visual modeler to get involved with the data engineers in defining the semantic layer. And we're trusted by many thousands of companies. So we have hundreds of paying customers and thousands of other companies who use us as well, and with our open source offering, and really great feedback from many of them, and many great customer case studies that we can share. And we've been ranked a leader by GigaOM for 2 years in the semantic layers categories, and they're very. We are a leader in that and our flagship, and we have a flagship offering that is market leading. And that's it from me, and I'll hand over to Yali.
Thanks, David. So really nice to meet you all. I'm going to dive straight in. My name is Yali. I'm a data enthusiast, a data nerd, and co-founder and CTO at Snowplow. So I'll just very quickly introduce Snowplow to you all. The starting point for Snowplow is behavioral data. So data that describes what people are doing second by second and minute by minute. And as a data person, behavioral data is really exciting to me, and I think it should be really exciting to you, because if you're interested in using data to understand people and how they make decisions and then predict those decisions and influence them, there is no better data set. And over the last kind of 20 years and more, as more and more of our lives have moved to digital platforms, we now have opportunities to collect this data with huge granularity and great accuracy and do some really sort of amazing things. This data is incredible fuel for AI. And so Snowplow has been around since 2012, and in that period, and that's a long time in data, we've seen it when we launched be used primarily for analytics use cases, but pretty quickly that data has been adopted for machine learning use cases, kind of classic machine learning, think recommendation, personalization, dynamic pricing, promotion, fraud detection, bot detection, those sorts of things. And the really exciting thing that we're seeing happen now is that data is starting to be used in this new generation of agentic applications. So a lot of those early agentic applications are agents. David talked a little bit now about data agents, but we're seeing support agents, personal shoppers, beauty advisors, personal trainers, all kinds of agents, and the ones that I've listed here are just the customer-facing ones. That people are creating all kinds of different agents, and this data is really, really valuable for powering those use cases. The data is powerful for powering those use cases. It's rocket fuel because it's so predictive and so explanatory, because you can see what people are doing and see the decisions that they're making and all the environmental variables that are true as they're making them. So it's wonderful that it's uniquely valuable, but unfortunately it's uniquely challenging to use. And there are technical, organizational, compliance reasons for this. It's in most organizations, this is the highest volume, highest velocity data set that the organization has to deal with. It's streaming in from multiple different channels typically, and it's 1 or 2 orders of magnitude bigger than the next data set. In a typical enterprise, there might be more than 100. We work with organizations that have more than 400 different data producing teams. And every one of those data producing teams is also a data consuming team. And there'll be other teams that are just data consumers. So you're looking at hundreds of different data consumers. So figuring out how to coordinate across all of them, manage things like the meaning of the data, the semantics, the governance, the quality becomes really challenging. And because that data describes what human beings are doing, it's personal. So it's subject to a whole raft of compliance challenges. And if you're a global company, you've got different customers and different geographies subject to different laws. So it's a bit of a minefield figuring out what you can collect and how you can use all that data. And it's not true that one size fits all. So uniquely valuable, uniquely challenging. And our job really at Snowplow is to build technology that helps meet those challenges so you can use that data as fuel for those different applications. There's different analytics applications like attribution, if there's machine learning, kind of 1.0 use cases like recommendation, personalization, and for the next generation of agentic applications. So things we focus on are giving our customers tools that can make sure that the data that they deliver is high quality and trustworthy. So, tooling to set up accurate tracking and catch data quality issues as close to source as possible, real-time alerting, those sorts of things. Real-time processing is really important. It's very common to use this data to power a set of real-time operational use cases like personalization and fraud detection, where any kind of delay is going to break that use case. Another thing that we think a lot about is delivering the data in a way that makes it really easy to feature engineer on top of. So time to insight, time to feature, time to prediction are really important. And so capturing metadata about what the data means at the point it is collected. It's actually before any data flows, our technology guides customers to define the meaning of the data that they want to create. And then we use those definitions to auto-generate the tracking SDKs and the data processing steps, and even downstream to populate a semantic layer. So there's that governance and understanding all the way across the data pipeline. We then have models that take that data and perform common aggregation so that it's easy to feature engineer on, because this data is very predictive, but it's not easy to typically feature engineer with kind of traditional behavioral data from other sources. And now in the agentic era, we're using our technology not just to track human behavior, but also the behavior of the agents that are working with that data. And that means you've got the full OODA loop. You can see what people are doing. You can see what decisions agents are making about people, and you can use the data to optimize, get those systems being learning systems that understand what they did that worked, what they did that didn't work, and improve and learn over time. 3 components to the platform: a data pipeline at the heart, a data management layer that does the governance, but is very tightly integrated with the data pipeline, so we can build kind of data quality and assurance into the data manufacture process, and then a set of data applications that make it easier for our customers to execute some of those use cases quickly, because we see a lot of commonality in use cases across our customer bases in retail, financial services, tech companies, and media. At the core of our tech is a data pipeline. A company like a media company or a bank or a retailer will have multiple different platforms, channels, web apps, mobile apps, TV apps, and so on that they're engaging customers on. Our SDKs will be creating data that flows through this real-time pipeline. We're validating that data, enriching that data, dropping that data in the data warehouse, modeling that data, feature engineering that data, and then delivering that data into the Kafka streams, the lakes, the warehouses, and so on, where our customers can go and build applications that use that data to create value and solve different use cases. And we're used by some really amazing teams and some really amazing companies around the world. It's a real privilege to work with these folks and see what they're building, especially now in this kind of agentic era. But that is me. So I'm going to hand over to Sean now. Thank you very much.
Thank you, Yali. Great to meet you all. Let me hop in and quick way of introduction. Sean Knapp, I am the founder and CEO here at Ascend, but I think more importantly, I'm a recovering CTO and data nerd. Prior to starting Ascend, I ran a 250-person data and engineering organization, powering consumer experiences for about 200 million users around the globe. And one of the reasons why I started Ascend was I really wanted to help solve what I felt were a lot of the common challenges across data engineering and analytics engineering teams. And one of the more exciting parts now of being on the vendor side as opposed to the buyer side of the table for some cool technologies is you get to work with some really exciting customers. And we work with a number of customers around the globe, from healthcare to retail, finance to media. And some of the really exciting parts about this is that we've been able to find a lot of common patterns and help really a large number of teams increase their overall productivity and velocity. And we do that with our product, which is the Ascend Data Automation Cloud, which to give folks a little bit of a visual as to how this actually looks. What we try and do is unify what are the verbs of data engineering. And when we think about what do data engineers and analytics engineers do, it's ingest, transform, deliver, orchestrate, and observe. And we do this time and time and time again. But what we have found over the course of our time is that there's this tremendous advantage in pulling together these capabilities, sharing the metadata, sharing the automation around how these systems work. And in doing so, we can give really great leverage for our customers and for the developers. And to kind of highlight a little bit of our journey and some of the things we've done, we've obviously received a lot of recognitions across the space, whether it's Dresner, GigaOM, Ventana, and Gartner. But the key sort of parts that we're really excited about is we're finding this consolidation across the space where many larger at-scale companies are starting to find that actually unifying more of these capabilities, pulling them together, really introduces a dramatic increase in the speed and the rate of innovation across their data teams. And the reason why I think that becomes so important against today's landscape is actually some data I want to share with folks. And the data I want to share is every year we do a really fun survey. We intentionally go out to market and we interview hundreds and hundreds of analytics engineers, data engineers, architects, everybody from hands-on coders to leads, all the way up to executives. And we do this actually not across our customer base, as that would be a biased data set, but we actually ask a large number of them about the various challenges they're facing as an organization, where they're making their investments, what's slowing them down. And I think this is particularly relevant as we head into this new era, as I do think data teams are the most well-prepared teams to do really innovative things when it comes to AI. But I think one of the challenges we face is we've consistently found across our survey that the overwhelming majority, 95% of teams, report being at or over capacity. Only 5% have any time to do anything new. And this becomes, I think, pretty important, especially when we look against that backdrop of increasing demand on the teams and increasing burden. It really puts this incredibly high premium on how do we increase the capacity, the efficiency of these data teams. And so, as we drill down with our users on our survey, we found a number of, say, hotspots around data quality issues, maintaining legacy systems, which literally nobody likes to do, all the way up to just the fundamental limitations on the tools they use. And oftentimes, as we try and tackle these problems, it can be a little bit overwhelming and a little bit challenging to really look at where do you go and focus first. But we have found a pretty consistent theme across our customer base, or sorry, across the survey base, which is this huge focus on this notion of automation. And one of the questions we ask is a really basic question, which is, do you already employ automation today? Or do you plan on doing so in the next 6 months, 12 months, 2 years, never? And one of the really surprising takeaways that we had was only 5% of people today report that they use automation. Yet 85% report plans to implement automation over the next 12 months, which is pretty exciting. Now, I think it can be a bit challenging to define automation. I imagine if we went and surveyed all of the panelists here, or if we actually surveyed all the audience members, you would probably find a large variety of definitions of what is automation truly. But I think the key sort of takeaway that we oftentimes have is there's this like incredible demand in the space for people to want to offload more to intelligent systems to take a lot of the toil of data away from them. And so what we actually focus on, and one thing I would like to pose is a little bit of a mental framework for how we think about modern day data architectures, especially against this automation lens. How do we leverage far more of what the systems and the machines can provide to us today than what they used to? And while yes, we think of the table stakes, the things on the top and the bottom here. Systems have to be able to run in Python and SQL, high code and low code environments that data engineers and analytics engineers can use. And yes, they have to be able to ingest, transform, orchestrate, and observe on data. The magic really is actually now happening in the middle. And we think about this with really three fundamental layers. One is unified metadata. We think metadata in the modern era is as valuable as the data itself. And that includes everything from real-time access to long-term historical access to metadata. And unifying it makes so much sense because not only can we build automated systems that build and establish a much cleaner and semantic understanding of what is happening with the data as it moves through, but we can offload huge amounts of that building responsibility and that maintenance responsibility to these automated systems. And now as we pull in more AI, not just to build AI products, but to actually weave it into the data experience itself for our teams and our builders, those AI agents themselves can take advantage of the very same kind of data. And we think that actually starts to introduce a pretty magical experience for our users, those 95% who are at or over capacity and really can radically improve their overall happiness and productivity. Now, while it looks like this may be hard, and of course, I'm sure most of us on the panelist side here will tell you, don't try and build things like that. That's kind of our job, and go and try and use the products. It doesn't actually have to be hard or complex to employ the technologies like this. And so, what we've really focused on at Ascend is taking these complex architectures and complex capabilities, but really presenting them in a far more elegant and delightful experience for data engineering so that teams have these incredibly powerful capabilities at their fingertips, but don't get consistently pulled back into the muck of the sort of toil of data engineering itself. And that part we're really excited about. But I would generally say don't take our word for it because we can pop up on stage and obviously say all of these really fun and exciting things, but our customers are the ones that really are the ones that have highlighted tremendous gains in productivity and happiness because of the kinds of things that we enable them to do. So with that, let me pass it over to Seth here, and I'll look forward to the session with everybody a little bit later on.
Great. Hi, everyone. I'm Seth. I'm the Director of Field Engineering at Materialize. So I'm the guy that gets to work with all of our customers and sort of dive into the weeds with them. Been here for a number of years. Prior to that, helped build an open source stream processor called Apache Flink. So been working in the data space for a long time. But today, I want to talk about context. How do we make we have these really powerful large language models, these world models that can provide information, but how do you give them the right context such that that information is worth something? How do you make sure that context is relevant, accurate, and timely so that we can get intelligent real-time interactions? I don't simply want these things to tell us something, but to be able to take action on our behalf. And so a lot of the work in the data space the last couple of years as these sort of LLMs have taken off has been in RAG, retrieval augmented generation, where you can make the knowledge inside your organization available to these systems. And so imagine we're some online retailer and somebody asks a question, when can I get an espresso machine delivered? Well, that RAG is going to have access to things like your knowledge base that says standard delivery is 3 to 5 business days, but can be expedited in certain scenarios. Maybe it has access to some data from your data warehouse. Hey, here's our morning inventory report. And we know that this morning there were 10 machines in stock. And it can provide that information to the customer. Hey, this morning we had 10 in stock. Probably still some. And the estimated delivery times will be based on your location. Maybe here's some links to give some more information to use. But it's not helping drive the sale forward. It's not taking action. What it needs is access to live structured data where you can see what is happening in your business right this moment so it can give the best possible result. And what that looks like is taking all the information we just provided, but some additional. Hey, here's live inventory. Yes, there were 10 available this morning, but there are 7 available right this moment. And we can see this specific user is located in Brooklyn and has a gold membership. And suddenly the response is very different. Instead of telling them things that they could find in our documentation, this AI agent is able to say, hey, there are actively 7 available. If you make a purchase, it's going to be there. And because you're in Brooklyn and have this membership, you qualify for same-day delivery if you order right now. It's pushing your business forward. It's helping people take action because it's not treating this user like a stranger. It's leveraging all the information you have available about both them and the business. But what makes this difficult is getting access to that live data. You already have this. It's in your OLTP databases, your Postgres, your MySQL, your Oracle, your SQL Server. And by definition, that data is very fresh. You add something to your cart, it's in the database. But these systems are built for handling transactional workloads. They're not for OLAP-style queries or the really heavy number of reads you might be running when you're not just running at human scale, but agent scale. And so these are going to be slow, or it might be expensive. They might just fall over entirely. So traditionally, the answer for this has been to move into the cloud data warehouse. And that's really wonderful for reporting. It tells us every morning what our inventory is, what needs to be restocked. But by definition, the cloud data warehouse is stale, right? Data does not flow immediately from your OLTP system into the warehouse. And importantly, it's not immediately flowing through all of your models. When we update inventory, when somebody purchases a record, how long does it take to get that data extracted from the database into the warehouse and refresh all of your views or tables? And so this is stale and not giving us actionable information. And finally, you can roll your own. Like, this is where microservices tend to come into play. People build their own streaming infrastructure, but that becomes a talent bottleneck. And so what these AI systems want is the ability to enrich their prompts with the information that you get from OLAP style queries, but on your OLTP data. without compromising on the fast queries, right? We want to reduce that end-to-end inference latency. When I ask that information, I want it there right away so we can respond. It needs to be fresh, so giving us the latest value, right? If somebody inserts something into their shopping cart and then asks the support agent about their shopping cart, it needs to know what's there. And we need strong consistency, not just in terms of the way you interact with this, but truly in the database sense, strict serializability. When we update a row, we want to ensure that we see it on the very next read, and that all of the different views built on top of our data are in sync with each other. So when you look at more than one piece of information, you can guarantee it all makes sense. The numbers should always tie out. We need to be able to get that data from wherever it resides. So you have an OLTP database, but you probably have more than one. They might be different flavors, either Postgres or MySQL. It might be data that lives in Salesforce. That is, after all, a database with very important information. Or coming from a number of other places. And like everyone will always say, it needs to be with SQL, right? You want this to be accessible with the team and tools that you have available today. And so that's what Materialize is looking to offer. It's a real-time data integration platform that gives you the ability to transform, deliver, and act on fast-changing data just using SQL. So you can bring together data sets from disparate places, join them, you write SQL, and these results are kept always up to date as the underlying data changes. We do all of our work on write. So that means that when you go to query the system, it's very fast because all the work is done, reducing that end-to-end inference latency, and with strong guarantees about the correctness, that it's always up to date and it is always highly consistent. And then from this, we can build these real-time customer 360s that your models can now leverage to say, I know this specific user. I know everything about them at this moment and can give them actionable details based on the query they have. So support is one great example. Another might be live portfolio integration. Somebody shows up and says, hey, should I make this stock trade? We want to look at live market data. We want to understand the results as they live, or something like fraud. Places where you need to bring together all information, you want to keep it fresh, you want to transform it, and make it available right away. So with that, thank you. I will give it back to Stephen.
Thank you very much, Seth, and thank you everyone for those great presentations. So we're going to get everyone up on the screen and do our kind of Hollywood Squares thing and dive into our group discussion. So David, you're going to be our leadoff hitter. A lot of pressure. First question to tackle. In your opinion, what is the greatest challenge currently facing organizations when it comes to modernizing data management for the AI era?
So I think this is exactly where we've been focusing on. The problem with it is that the data, and this is OLAP data that we're talking about, and not unstructured data, which I think is there are different approaches for. The problem with that data is that it's often a bit of a mess. People have ingested things left, right, and center. They have development data lying around everywhere that hasn't been dealt with. And it's difficult to know without being an experienced analyst who knows where things are, or an experienced data engineer, exactly which data to use, what the columns mean, how to join it together, how to aggregate things in the right way to come to the right answer. It's really difficult. And that metadata, which is what it is not particularly well kept. It's not stored anywhere or codified usually, unless you have a semantic layer, which is where you can do that and then use those definitions over and over again and make it easy to access the right data and to only expose the right data that you want people to see. So and I think it's really interesting that actually what makes it easy for humans is actually what makes it easy for AI as well. When you have well-named objects in your semantic layer about customers or orders or whatever it may be, and you've named them clearly, you've named them distinctly, you've got good descriptions, all those things which a human can benefit from, AI benefits from, maybe even more so.
That's a great point, David. Yali, would love your input. Do you agree with David, or do you have another top challenge in mind?
I'd agree with him, but I'd widen the aperture a bit. I think data management is hard. It's hard to govern your data. It's hard to manage your data. The tooling has got better and better, and I think all of us have here on the webinar have technology that makes it easier, but it's still hard, and I think we've got to be honest about that. And the reason it's hard is because a lot of the challenges are people challenges. In a big enterprise, you've got data all over the place that's managed by different people. So the fact it's in different systems is challenging, but those systems are managed by different people. And if you want to understand what that data means, you've got to go back to how that data is collected and the behavior of those people around those systems. And if that changes, then the meaning of the underlying data changes. And the pipeline from source to using the data in an AI model or feeding it to an agent might be long and arduous, and it might not be completely clear what's happening at every stage. So I think organizations today are in like various different stages. Most of them have some well-governed, well-understood data. Hopefully that's in a warehouse with a semantic layer on top, and they'll have multiple other data sets around it that are less used. And when that organization is going and trying to execute different AI use cases, they might get lucky and the data that they need is in the well-governed pot, and they might be unlucky and it's not. And then it's a people process, bluntly, to go and figure out, is the data there? Can it be put together? Can we then, once we've got the data, manage the ongoing delivery and make sure it doesn't change in ways that break the downstream system? So I think AI is helpful because it means that we can build better tools to support people doing this, but we can't change the fact that fundamentally it's a people problem, and people problems are difficult to fix, especially when there's a lot of people involved.
That's a great point, Yali. And yeah, every organization is kind of, at a different stage in the process there. Sean, what are your views on this question?
I look at it starting kind of from the top down, which is the number one problem I think that data engineering teams face is a productivity problem. Uh, if the if you could sit down with every data engineer or analytics engineer and ask them, hey, describe what it feels like when you're adding peak value, which is probably strongly correlated with their favorite part of their job. And then you ask them, so what percent of your time are you actually spending doing that of your day? It's a very small percentage. And so I think I definitely agree with what Yali's saying, which is it's a people problem, and I think even more so it's an organizational and platform problem where it's not always even just data silos, but tool and permission silos. And I don't think the industry has at large figured out how to really embrace what DevOps did around enabling more software engineers to move faster yet safely. I don't think we've found this in the data ops realm yet to, again, oversimplify, but we haven't figured out how to enable far more people to move fast yet safely in the data realm. And I think that's where, obviously from our lens, we look at the more you can automate, the more we can use AI as a boost to teams, the more we can actually get them at higher revs every day and be more productive and get them just out of the toil, which is I'm still, I wrote my first data pipeline literally in June of 2004. And I'm still 20 years later, just surprised by how much toil we are willing to accept in this industry compared to, say, software engineering. And so hopefully over the next year or two, we really see a remarkable shift in that.
That's a great point, Sean. There's always that trade-off between moving fast and then, reliability. And yeah, that was a really interesting survey. Seth, we're on to you. You are batting cleanup on this question, but I'm going to let you go first next, so don't worry. So, where do you stand on this? Anything you'd like to add?
Yeah, I think, some of this might just be with the problems that I work on. I tend to be a little different. I don't disagree with anything that anyone said here. Certainly, being able to understand where your data came from, control it, make it available. These problems have existed. They are only exacerbated in the space. What I have seen that's been particularly interesting is the type of data that these systems want, and particularly when we're looking at RAG systems, which is where I have been spending a lot of my time, which is that data teams have historically focused on things that you could call reporting. We want to understand our business. We want to see what is going on. We want to be able to take action. Where these AI systems really want to live in the operational space, and they want to live with your OLTP data, which is always changing, but they still want to run those complicated queries. And how do you make that available? Like, this is where sort of fundamentally new challenges for data teams come in that have not had to worry about, millisecond level freshness from when a row is updated to when it's available. Just to sort of keep that example going, you add something to your shopping cart, and then you want to go ask your support AI bot about it. It better know what's in your shopping cart. Otherwise, it's not helping you. And that LLM is not driving value towards the business.
Understood. Yeah, with changes, you can get new challenges as well as opportunities. It's constantly evolving. All right, Seth. Well, I promised I'd let you go first on our next question. So that is, what trend are you most excited about that you think will have a greater impact on the market moving forward?
Yeah, I think that what we're finding is that AI is blurring the line between data engineering and software engineering. And certainly a lot of tools have been trying to drive that as data's moved from somebody logs in and just writes a SQL query or creates a view towards we now have tools that allow us to check in our SQL as code and maintain it, manage it, and have CI/CD pipelines. These AI systems are putting just so much more load on these data systems. They're making them part of your operational space. Data is now powering applications that end customers directly interact with in a very real way. And, really, I think this is what's going to push us into really rethinking the separation between data engineering and software engineering, and if there is a separation at all.
Understood. Sean, where do you stand on this?
Yeah, I would actually agree with and build on top of what Seth is saying there, which is I think we are seeing more software engineering influence come into the data engineering space. And similar to as I was mentioning before, um, more of these DevOps translated into data ops principles, which I think is really great. Um, and again, if we put that against that backdrop of we want more people to be able to move faster yet safely. Software engineering has, I think, really demonstrated a really strong ability to do that. And so I think, we're going to continue to see far greater processes in place and far greater tooling that will drive more automation, drive greater adoption of AI across these data teams, uh, really specifically at driving greater overall efficiency and productivity.
Thanks, Sean. Yali, what do you view? What's the trend you're most excited about?
I might come back to the point that Seth sort of started. The I think with with the kind of agentic applications, the capabilities that they now have, we all collectively have the opportunity to rethink the way run kind of end-to-end business processes, or the way that we deliver end-to-end customer experiences and customer journeys in a fundamental way. Instead of looking at like each different part of it and optimizing it, we can rethink the whole in radically different ways. Like, you know, a boring example, but think about how somebody goes and books a holiday, and the nightmare that process is today, sort of thinking about destinations and flights and hotels and itinerary, and pulling that all together and booking all those things individually, and rethinking that in a kind of an interactive and agentic way. So if we are, as data people, supporting the people building those applications, like the need for data and the way those applications are going to need to access and manage data is kind of mind-boggling. We're going to have to get much better at managing data. To Sean's point, we're going to have to like enable them to run much faster without breaking things, and we're going to have to, you know, expose data much more quickly and make sure that it makes sense a lot faster. So we're going to have to get a lot better, a lot quicker. I don't know if that's. I find that very exciting. I think the reward on doing data management well is going to be enormous, but there's a lot of work for all of us to do to make this sort of vision a reality. But that's exciting. It would be boring if it was easy.
I love that you brought that up, Yali, because, you know, I've been following agentic AI, and, you know, right now it seems very early stage. There are still certainly limitations and challenges with that. But I personally like the idea of an AI assistant that could book the flight based on the parameters I want, book the hotel, book the rental, et cetera, et cetera. And that's just personal life stuff. David, you're batting cleanup on this one. What trend has you most excited?
Yeah, one of the things that I've personally been playing with is actually using AI in development, so for data engineering work. And so I've just been using actually more general purpose AI powered IDEs that really are meant for more for software engineering than necessarily data engineering. And so you've probably heard of some of these like Windsurf and Cursor. And I've just found the experience really powerful, because where you might spend hours or a long time just like working, just banging your head against the wall trying to get some kind of configuration to work, these things, they just get those sorts of boilerplate bits of code out of the way in seconds or minutes sometimes, and you can scaffold whole projects really fast. And sure, you definitely need to know what you're doing, but I can read that code and know what it's doing, and know that it's doing what I want it to do. But I'm just I was just so much more productive, and actually so much more ambitious. Like some of the things I set out to build, like I built an integration between another piece of software and Cube, and I'd never have thought to do that, or that I'd have the time to do that before using this kind of tool.
Understood. Thanks, David. I want to make sure we get to some of our attendee questions as well. Yali, I was going to let you go next anyway. You haven't had a chance to go first yet. But
Thanks,
perhaps
David.
you can weigh in on, I know we're getting close to the top of the hour. We're going to take as many questions as we can, but I was going to ask, about kind of key components of the modern data environment to support AI, and this, could theoretically be one of them. I'm curious for your opinion on it. The question from one of our attendees was, how do you envision the role of data mesh in the application of AI?
So I think data mesh is a really interesting approach to organizing people around data and data applications that's decentralized. So the problem of data engineering and central data teams being kind of overworked is very real. Sean talked very articulately about that. And one way to tackle that is to sort of decentralize ownership of data and data sets, and also decentralize ownership of the data applications, your AI models and so on that use them. And that only works if you've got the right people with the right skills, and it only works if you've got the right technology supporting it. So it becomes really easy. The cost of being an owner of a data set or the owner of an AI model is low because you've got great tooling that lets you create that, manage it, monitor it, publish it to a catalog so other people can discover it and build on it. So big fan of data mesh because it addresses the fact that these are people problems, and think it's very valuable for an enterprise going all in on AI because you're really enabling the organization to scale AI effectively over it. But the big challenge with it is culture and people. You need the right people with the right skills, and you need to equip them. So the tech helps, but it's not the biggest challenge here.
It's not just the tech. Understood. Sean, I'm going to offer this to you next. And if you're not big on data mesh, you can feel free to talk about what you view as other kind of key components. That was kind of one of the original questions I had in mind. Like, what should companies out there regard as key components if they want to modernize their data management to really be able to take advantage of AI?
Right. Well, I am actually really big on data mesh. I think it's the software engineering-ification of data in many ways. Let me explain. The software teams, especially in a modern DevOps culture with microservice architectures, which I think has been part of the design that has really transformed software engineering and dramatically increased productivity, had a simple construct. Small teams, nimble, create a service, produce an API, and that's your contract to the world. And that team operates independently from others. What we see with data mesh is a very similar model that Yali was describing, which is smaller, more nimble teams. You are responsible for your data products. You produce your own data contracts. You hit your own data SLAs, and then organizationally, you can keep that on the rails, and you can actually drive that adoption. You get more autonomous, more independently executing units that can move faster and more nimbly. And so, in many ways, I think these notions of data mesh and data ops are very similar to what we saw around microservice architectures and DevOps in the software realm. And I'm incredibly bullish and would love to see more teams adopt architectures and strategies like this.
I love the comparison there. David, would you like to weigh in on data mesh or other key components?
Yeah, so I probably build on what Sean was saying in that, because of that kind of microservices architecture where each team's like looking after an API or collection of APIs, it actually really plays nicely with, I think, the agentic kind of future that we're looking at, because those APIs and data products, they're well described, well defined, products. And what can happen is that within an organization, you might have a whole collection of those, and that might actually be quite difficult for a human to know exactly where to go to find which thing, and you'd have to go through some kind of service catalog or something to figure out where to find them. But if you were to have them as part of an agent framework, those APIs by themselves are actually a lot simpler than what would be accessible in a wider data architecture. So the agent could route, questions and choose the right part of the mesh to go to, and then query that API to answer the question. And I think this is actually kind of like also comes back to like where Seth was saying these AI agents want to be a bit closer to those OLTP systems because it's kind of being routed to the correct like record of truth.
Understood. Seth, I know this question is of interest to you. So where do you stand on data mesh?
I'm going to agree with what everyone has said. I do think what is particularly exciting, I agree with what everyone said, I don't feel the need to repeat it, is that not just are teams making data available, but as we spin up agents, They have data they need to make available to other teams, other people, but also other agents within your organization. And data mesh gets to be the tool in which you have not just 10 teams with 10 different services, but 1,000 agents that all need to communicate with each other. And not only are they taking action with the outside world, but they are presenting information to each other to coordinate, for you to understand what's going on. And data mesh, I think, is going to be very finely ingrained in how agents are deployed and monitored and maintained and coordinated in sort of modern stacks.
Fantastic. All right. Well, I know the classroom bell has rung, but I have one more question for all of you. Our attendees are very graciously staying with us. They have not rushed out yet. So that question is, and Sean, why don't we start with you? If there's one thing you would really like our audience today to walk away keeping in mind, as well as future folks that view this webinar on demand, what would that be?
I would love for folks to walk away with there's universal consensus, 85% technically, that automation's a thing and a very important thing. And I would strongly encourage people in the audience to come up with a plan and really start to think hard on how do you employ higher levels of automation to get your team out of the toil and into the building.
I agree 100%. You know, at the end of the day, most of this isn't about job replacement. It's about allowing data engineers as well as other professionals to focus on more value-adding initiatives. Seth, we're going to you next. One thing you'd really like everybody to walk away thinking about.
I think, that these systems absolutely thrive on fresh, highly consistent operational data. Right? These are not just static documents. This is not your reports from yesterday. So that they can deliver exactly the kind of context-rich, actionable insights. And it's moving these data teams, frankly, from cost centers in your organization to profit centers. We are running the systems now that people are interacting with, and not just helping to service those parts of your organization.
Fantastic. Okay, David, you're next. One thing you'd really like everyone to walk away keeping in mind.
So I keep hearing from either customers or other people I know in the data world that their C-suites or whoever is leading their companies are asking again and again to have AI, access to data, AI access to XYZ. They that's what they want, and I think it's better to actually just think this is going to happen. And you need to prepare for it. And if you think about how to prepare for it, come up with a plan. And a lot of the time, that plan is somewhat rational. Making your gold data easy to understand, clear, distinct, described, and these are like good housekeeping things that you probably would have wanted to do anyway. But you can now consider it. This is how I'm going to prepare for AI interaction with my data by whoever it may be.
I think that's a great point, David. And a lot of AI readiness initiatives are things that would improve, the value of data and how it's used at organizations to begin with, whether it's on the governance side, the integration side, et cetera, et cetera. Yali, I saved you for last. So if there's one thing you'd really like our attendees today to walk away keeping in mind as they go about their day, what would that be?
So look, there's a lot of exciting possibilities, but it's daunting. A lot of challenges to overcome. So the big thing I'd say is be pragmatic. Don't start with the data. Don't start with the data management. Start with the use case. Start with the thing you're trying to drive the difference in the business. If that's an AI application or if that's something a lot simpler, and work back. What's the minimum you need to do in terms of data management and data to enable that use case? Get it live, celebrate it, tell everybody about it, and just build up use case by use case. And some of them will work and some of them won't work. And over time, you'll get to build the the practice and the like all the relevant supporting things, but just be delivering value all the way through. Because I think in the last 10 years in data, we've often started from the left to the right with the data up, and that doesn't always work, and the business sometimes loses patience with us.
I think that's really smart advice. Well, I would like to thank all of our speakers. Big hearty thanks for coming on board and sharing your insights and expertise. Once again, folks, David Jayatilaka, VP of AI at Cube, Yali Sassoon, co-founder and chief technology officer at Snowplow, Sean Knapp, founder and CEO of Ascend.io, and Seth Wiesman, director of field engineering at Materialize. So if you in attendance would like to review this presentation or send it over to a colleague, you can use the same exact URL that you're on right now for this event. It will be archived. You will receive an email notification once the archive is up. And if you want the deck, you will be able to download a PDF from the recording. You go to the handout section once that's live. Thank you, everyone, for joining us today, and we hope to see you again soon.